Good morning, everybody. Happy to kick us off today. And before I get started, I just wanted to say a big thank you to Caitlin and Abby. I work with them every day and know how hard they work to put this together, and I know it'll be great. So big thank you. And also thank you to our local community members who are here today. I'm just really grateful that so many of you show up to learn more about our local waterways and be ambassadors for the quality of life here in our community. So one of the most common questions our field staff get when they're out working is, how's the water? Because the quality of our estuarine waters is important to the quality of life for all of us. And over the recent years, we're all too familiar with news reports from around Florida of toxic algae blooms, wildlife deaths, economic hardships for those whose jobs depend on clean water. So what is the state of the water in GTM estuary? So first I'm going to start with a quick introduction about what I mean when I say water quality. Basically, I'm thinking of three main categories: eutrophication, bacteria, and other contaminants. Eutrophication, you can understand by kind of breaking up the word into its roots, well and nourishment. Basically, it's the process of feeding an estuary. And estuaries are naturally fed and nourished because they're where the land and the sea intermix. But of course, you can have too much of a good thing, and excess nitrogen and phosphorus can lead to excess algae growth, decreases in water clarity, low oxygen events, and toxic algae blooms. So the pictures up on the right are examples of how nutrients can enter the estuary in our local watershed. Another category of water quality is bacteria. And we measure fecal indicator bacteria particularly. And these are bacteria that are found in the guts of warm-blooded animals. And so the fecal matter from wildlife, livestock, pets, and humans can enter the estuary. And human sources can come from like leaky septics or sewer overflows. And really the fecal bacteria are usually not that harmful for humans, but we call them indicators because they are indicators of pathogens in fecal matter that can be harmful to humans. And then lastly is this category I'm calling other contaminants. Basically, this is all of the products we use and the medicines we take that get flushed down the drain. And they're not always treated very well by our current wastewater treatment technologies like wastewater treatment plants and septic systems. So I'm going to address this question, how's the water, in a few different ways. First, by giving you some personal observations from my past research, introducing you to how we monitor water quality at the GTM, and summarizing some recent findings from a statewide assessment of water bodies. And then hopefully I'll have time to talk about some recent findings by visiting scientists regarding water quality. So here's some pictures of me in grad school. I'd love to start with a little story. So I was doing research in the GTM estuary in grad school in the early 2000s. And basically figured out that our estuary is relatively resilient to the negative effects of pollution. And one of the reasons is that we have these two inlets to the estuary. So the water comes and leaves the estuary in about 2 days to 2 weeks. So it really doesn't have enough time to sit around and grow algae like some other estuaries do. But also, we are really fortunate to have an extensive intertidal oyster population. So I did some back of the envelope calculations back then to figure out how much water oysters could filter, and figured out that basically they filter the estuary within 8 to 25 days. So it's a similar time scale to that flushing by the inlets. So I'm excited to share this with you because recently, last year, we published a paper. We were able to work with some modelers to really improve those back of the envelope calculations I did in grad school and quantify the filtration services of oysters. And basically, oysters filter about 60% of the water in the estuary in less than 2 weeks. So I think we can be really grateful for these guys and hope to protect them into the future because of this. So in terms of what we do at the GTM for monitoring, as Heidi really well laid out for you, we're part of this national program, 30 reserves around the country. We all monitor water quality the same way. We have standardized protocols. And at GTM, we've been monitoring these 4 fixed sites we are in our 20th year of monitoring. And at each of these sites, we're collecting 15-minute data on things like temperature, salinity, oxygen, pH. And then every month we visit the sites and collect water to send to a lab for nitrogen, phosphorus, chlorophyll, those kind of eutrophication indicators, as well as bacteria and other parameters. And you're going to hear a lot more about this program from Shannon right after me. But what I love about working for a NER is that we're not only nationally significant, but we're locally relevant. So over the past 5 years, we've been able to fill a data gap by monitoring 10 sites in the Iguana River estuary, by working with partners. And you'll see from Olivia's presentation after Shannon that we've been able to make some progress, and it's really exciting. So stay tuned for all of that. And so because we are out of reserve and we want to affect coastal management, we try to have a really applied focus. And we're challenging ourselves this year to not just use our water quality data to plot out monthly concentrations of nutrients, but really looking at what is the nutrient status of our different water bodies. And this will help us really be able to develop protective policies and remediation strategies. And so to figure out what the nutrient status is of a water body, we're following this model by this Cloworm paper, which I encourage you to check out. But basically, it's different ways of looking at nutrient status, like using nitrogen and phosphorus concentrations, chlorophyll concentrations, which are an indicator of how much phytoplankton are in the water, and then proportions of different nutrient types. And so you'll see some examples of these indicators in Shannon and Olivia's talks. Okay, so now I want to kind of summarize this recent state assessment that was done by DEP's Division of Environmental Assessment and Restoration. And they do this according to Clean Water Act and Florida Impaired Water Rule policies. So basically every 2 years, the state assesses the water quality of every single water body in the state. And they use a database of water quality data that is submitted by various public agencies, including us. So we submit data to this database for our estuary. The water bodies that are determined to have an impairment for a particular parameter will have a restoration target developed called a total maximum daily load, or TMDL. And then DEP works with the different people in the watershed who are contributing to those pollutant loads to develop a basin management action plan to meet those restoration targets. So that's the state process. And in terms of the assessment itself, each water body gets a score from 1 to 5. So if a water body is a 1 or a 2, it's meeting its designated uses, which is recreation or fishing. If it's a 3, there's not enough information to assess the water body. If it's a 4, there's a possible impairment, but there's still some questions and studies to figure out. And if it's a 5, it's officially listed as impaired, and then that TMDL and basin management action plan process kicks off. So I don't have time to go into all the details of the assessment, but I wanted to share with you the impaired water bodies that were designated for the GTM estuary this year. So this is a map of all the water bodies that are impaired for nutrients or bacteria, or both. So if you look at bacteria first, which is the gold polygons, you can see that there are quite a few water bodies with bacteria impairments. And most of them are the freshwater or brackish tidal creeks or tributaries to the estuary. The brown polygons are the nutrient impairments. So the Tullahmata River is impaired for nitrogen. Oyster Creek, which is a little water body off the San Sebastian River by St. Augustine, is impaired for chlorophyll and oxygen. And then a couple of different segments in Palliser Creek are impaired for chlorophyll, bacteria, and oxygen. So I'm going to zoom in now to the Iguana River estuary. And because I said we've been monitoring this for the past 5 years or so, there was not enough data previous to our monitoring to be able to assess these water bodies. So the first one, there's 4 water bodies that make up the Iguana River estuary. And the first one to the north is the Ponte Vedra Beach area with the golf course and residential lagoons. These are basically the headwaters of the Iguana River. And that water body actually has the most nutrient impairments of any of the water bodies, impaired for chlorophyll, nitrogen, and phosphorus. South of that is the Sawgrass area and the remnant of the Iguana River that runs down just north of the Michler's Weir. That water body is possibly impaired for oxygen and phosphorus. And the reason it's a 4, not a 5, is because they're just need to do a little more study to figure out if they're classifying the water body right. And then south of that is the impounded portion of the river, or Iguana Lake, and that is impaired for chlorophyll. And then south of that, south of the dam, the last natural part of the river is also impaired for chlorophyll. So you can see there's some definitely water quality concerns in this estuary that we have discovered over the last couple of years. And so next steps for all of this is an official listing of the impairments in April. And then for those water bodies that were determined to be impaired, there will be some TMDLs developed and restoration plans will start being developed. It's a pretty long process. It'll take multiple years. But the fact that these water bodies are designated as impaired starts the process. So that's a good thing. And then next steps specific to Iguana River is actually the first example of visiting scientists research. We're working with University of Florida on a 3-year grant from the Nurse Science Collaborative, looking at basically how nitrogen moves into Iguana Lake, within Iguana Lake, and out of Iguana Lake. And then also looking at how mussels and oysters in Iguana River are affected by water quality, but also affect water quality. And all of this information will help us be able to develop a restoration plan for the Iguana River estuary with a bunch of stakeholders. So we've already started that stakeholder engagement process this year. So another visiting scientist example is Matt Brown from Flagler College and his students. Matt Brown is part of our Oyster and Water Quality Task Force, and he presented these results to us. On the left, thank you. So he samples 5 sites in the San Sebastian River, just west of St. Augustine, every month since 2019. And you can see this small, this small dot at where the San Sebastian River meets the Matanzas River is our long-term monitoring site. And what they've observed is increasing concentrations in bacteria as you go north up the San Sebastian River, with the highest concentrations up near State Road 16. And then they found kind of a hot spot of nitrogen in the middle of the San Sebastian River. And that's pretty close to where that Oyster Creek nutrient impairment is. So Dr. Brown is working with the city of St. Augustine and the Matanzas Riverkeeper through our Oyster and Water Quality Task Force to try to address this water quality impairment. And then finally, there is an ICOS project out of the University of Florida where they've started monitoring what are called PFAS compounds. You might have heard about them in the news. It's kind of an emerging area of research. Basically, they are forever chemicals. They don't break down over time, and they're found in common household items, food packaging, water-resistant clothing. And they have the potential to cause cancer, liver damage, decreased fertility, and interestingly, decreased vaccine response. So that's why they're an emerging area of research for sure. I know the EPA is looking into these a lot. So they measured PFAS compounds in the Matanzas River from 2019 to 2020, including during Hurricane Dorian. And out of 51 compounds that they looked for, 23 were detected. And at all of the sites, average concentrations were above the potential for human health harm. So this was all just published in 2022. I encourage you to check it out. It's something that we're going to be paying attention to as we go forward. So with that, I will stop and happy to take any questions.
Thank you so much, Dr. Dix. It's great to hear about some of the research projects and really get an overview of water quality efforts and concerns. Thank you for sharing that. We do have some time for questions. So we can take questions in the chat box, or if you would like to raise your virtual hand, we can take raised hand questions as well. We have a question in the chat box for you, Nikki. What is the definition of emerging pollutants?
That's a good question. I don't know the exact definition, but I think of it in terms of these compounds that we haven't really paid attention to in science and resource management until I would say like the recent decade or so. So they're of emerging concern is how I think about them. You know, basically man-made chemicals that we haven't thought about in terms of impacting human health or animal health in the environmental sciences so far.
Are there any mediation strategies for PFAS in our waterways?
Not that I know of. Another good question. Hopefully that's part of the emerging research. It's kind of trying to figure out if there are ways to maybe absorb these things and get rid of them. But it is kind of scary to think of them never going away and us continually adding more.
Along those lines, do you know if the reserve has been doing any testing for COVID in the water?
No, I've heard of other states doing that, but I'm not aware of any of that happening here.
Okay, thank you. I've got a few more questions for you. Can you give some examples of restoration practices that will help lower bacterial chlorophyll impairments?
Sure, that's a good question. So in terms of, you know, for example, I'm thinking a lot about the Iguana River Estuary lately, of course. Things that have been tossed around are either building treatment wetlands or restoring existing wetlands to function such that they process the nutrients better. There's also the idea of removing sediments or muck from water bodies to kind of remove that recycled source of nutrients. And then of course, there are things you can do in the watershed to reduce the source, like best management practices, you know, rain gardens and swales and better wastewater treatment options, septic to sewer conversions, all of those types of things. And then of course, shellfish are important, like I was talking about the oysters. So just, you know, conserving those populations and perhaps creating more where they can thrive is another strategy.
Related to the oysters, do you or anyone from the reserve or other researchers have concerns about the bioaccumulation of PFAS in our local oysters?
That's the first thing I thought of. So it's definitely, I think, an area that we should look into. We have some NOAA colleagues up in Charleston who have the lab capabilities to measure these things. Or we could also go for grants to work more with the University of Florida, but really start kind of getting a better handle on the distribution of these compounds, not just in our waterways, but in the seafood that we eat.
And with that, kind of getting an idea of what the threshold of harm might be for oysters, but also other organisms, you think?
Right.
This is a great question that I think a lot of folks might have as well. How does an oyster clean water? It might make you concerned about eating them.
Good question. Yeah, so it's interesting. Oysters don't actually filter dissolved nutrients, the nitrogen and phosphorus that enter the water, but they do filter phytoplankton. And the phytoplankton take up the nutrients in the water, and then the oysters filter out the phytoplankton. Those end up in the sediments on the oyster reefs and can either get buried or get resuspended back into the water column.
And we have a question about the impairment of chlorophyll concentration. It looks like when it's considered impaired, is it impaired at a lower concentration of chlorophyll, or is it impaired because of a high concentration of chlorophyll?
Oh, okay, a high concentration. So each water body has its own state threshold. So depends on which water body you're talking about. It can be anywhere from like 4 micrograms per liter to 11. And if the annual average basically for 3 years is above that, or 2 of those 3 years is above that limit, then it is considered impaired. So it really is not like a one-time measurement. They're really looking at like 3 whole years and averages. So if the average is above that threshold, then it is consistently above that threshold.
Great. Thank you so much, Dr. Dix.